Let's solve a linear programming problem. Find the maximum value for the objective function z is equal to 3x plus 5y subject to the following constraints. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is less than or equal to 6, and x is greater than or equal to 2. All right, first thing what we need to do is find the region where our solutions lie. And that's going to be anything to the right of the y-axis, as demonstrated by x greater than or equal to 0, and anything above the x-axis. So basically anything in the first quadrant. Now we have the equation x plus y equals 6, and that comes from our inequality less than or equal to 6. And again, because it's or equal to, we have a solid line as I've drawn here. Again, if you plug in a point like the origin, 0 is less than or equal to 6, so we're going to darken in everything down and to the left of our blue line here. Now we have our red line, x is greater than or equal to 2. That means any ordered pairs to the right of this red line have to be in our solution set. So let's tie this all together. It's anything in the first quadrant, down and to the left of the blue line, and to the right of the red line, above the x-axis. So we obtain this triangular region as our solution set. These are all the ordered pairs that give us a true statement for these four inequalities. Now what we have to do is maximize our objective function. Z is equal to 3x plus 5y. And the way we'll maximize this is by plugging in the corner points. The particular corner points that we have here are the points 2, 4, down here 2, 0, and the ordered pair 6, 0. So what we now need to do is evaluate our objective function 3x plus 5y, that is, evaluate the corner points into that objective function. And in this particular problem, when we plug in 2, 4, we get 6 plus 20, and we get a maximum value of 26. If you plug in 2, you're going to get a value of 6. If you 2, 0 rather. If you plug in 6, 0, we obtain a value of 18, which is not as large as 26. Remembering, we're trying to maximize this objective function. So we can say we obtain a maximum of 26, and this maximum occurs at the ordered pair 2, 4. So this is the solution to our linear programming problem.